everyone present here. I am Samrat Nirola, the team leader of the Olympus group. I am presented here on the fourth day of the school level satellite training to present a presentation in front of you all. Let's first understand what we have learned. Introduction to satellite. What really is a satellite? Satellites are celestial bodies or man-made objects that revolve around a planet under the effect of gravity, making an orbit. Some examples of the moon that we have all heard about is Moon, Titan, Ganymede, Deimos, etc. There are two types of satellites. They are natural satellite and artificial satellite. Now, we all imagine that why really are the satellites made? Well, there are bunch of reasons why satellites are made. Human beings have been making satellites from decades and launching them in the space. Some of the few reasons why satellites are made are listed below. Communications like our telephone, television, etc., ground navigation system, Earth observation, deep space, weather detection, geological studies, and studies of natural disaster. There are much more reasons that I have not mentioned here why satellites are made. Now let's understand about the orbit of satellites. What really is an orbit? An orbit is a curved trajectory flight path of an object such as a trajectory of satellite around the planet. Well, the orbits of satellites can be differentiated in three parts. They are lower orbit, which is up to 1000 kilometers, and middle orbit from 1000 kilometers to 36,000 kilometers. Geostationary orbit, and which is above 36,000 kilometers. Now let's understand what really a CubeSat is. We have learned about CubeSat. What really a CubeSat is? A CubeSat is a square-shaped miniature satellite, which are the dimensions of 10 centimeter into 10 centimeter into 10 centimeter, roughly the size of a Rubik's cube, weighing about 1.33 kilograms. Now let's learn about the pros of the cube satellites. It is far more relatively less expensive than large satellites. It takes less time to be manufactured than large satellites. The design to make cube satellites for smaller projects is not as complex as in the large satellites. They don't become the part of space debris as they burn up in the atmosphere upon G-entry. Now, there are a lot of cons of CubeSat as well. We have termed it as a swap. What really is a swap? Size, weight, and power. As we know, the CubeSat is made from 10 centimeter times 10 centimeter times 10 centimeter dimension. Due to its small size, the scope of CubeSat decreases because of the reduced capacity of the CubeSat to carry scientific instruments. Another big problem for it is its weight. The weight of a CubeSat must be strictly 1.33 kilograms, which is very hard to maintain after assembling all the essential scientific instruments within 10 times 10 times 10 centimeter dimensional cube. The next big problem for CubeSat is power. How will we power when it is thousands of kilometers far away from us? These are all of the possible problems that we have to figure out while going through manufacturing of CubeSat. The basic structure and system of CubeSat. The systems of CubeSat can be differentiated into many parts. Some of them are electronic power supply that supplies power to the CubeSat. For example, battery and solar panels. There is onboard computer, payload, storage, and communications. Now, let's understand what really we have made. The Team Olympus mission designing. The Olympus satellite. What really is Olympus satellite? And what is the purpose of it? The purpose of Olympus is to stay on the lower Earth orbit, regularly click photos, and send the data to find the rainfall timing accurately, which will help the farmers of Nepal that are suffering from decades due to the change in rainfall pattern. What are the uses of Olympus? The main work of Olympus would be to see the shift of monsoon clouds that comes from Bay of Bengal during monsoon season and predict the rainfall accurately. Now, let's go on to what are the payloads that we use in Olympus. To monitor the clouds, we will use infrared sensors or cameras. Infrared sensors can help in detecting rainfall by observing the motion of monsoon clouds. As monsoon clouds develop, release moisture and induce rainfall. The infrared sensors can capture these thermal changes, analyzing the data over time, enabling the monitoring the dynamics of monsoon clouds, predicting the rainfall pattern, and enhancing the understanding of regional weather system. Now let's understand the OBC onboard computer of our Olympus satellite. The OBC is the brain of satellite. It contains a microcontroller. It processes and interprets all the information.
30 seconds.
The OBC of Olympus sat contains gyro sensors, temperature sensors that will also help to find out the orientation and temperature of satellite. Now, what are the EPS of our Olympus satellite? So solar panels, rechargeable batteries would be used to generate power for Olympus sat, and to ensure the power supply is sufficient to support the continuous operation of the Olympus sat and sensor, include energy storage systems such as battery to store excess energy for periods when the satellite is in shadow. Shadow of sun.
Sun is not shadow. Shadow of shit. Shadow of earth.
Shadow of earth. When it is not facing towards the sun.
Yes, eclipse time.
Thank you so much. It is prepared by Team Olympus, and at last I would like to call my team member Jigyasa to let us know the feedback of this program.
Okay.
Thank you.
45 seconds.
First of all, I like to thank you. This program is very useful for us like students of 9 and 10. Because in electricity chapter we have learned this, but here we did it practically and it will be remembered for us for a long time of our life. They have showed us when we use one LED and when we put power supply it will burn. We have learned it by seeing them. And this program was very much affordable for us. It was very much effective for us because this satellite project also helped us to make friends as well as teamwork. I like to thank.
Okay, thank you. Thank you. Hi. Jigyasa with us. Shake hands. There we go. Good. Last but not the least. Out.